We are going to install ComfyUI and look in details how it's work. We're also going to work with two models, Flux and Stable Diffusion. ComfyUI by itself does not generate it. It is provide UI environment to work with different generative models or different components. Those components is what allowed us to generate images or animations. And we are going to use Stable Diffusion 3.5 as well Flux in this. Flux and Stable Diffusions are both AI models. They are generate image from text prompt, but they have some key differential. So let's look first on architecture. The Flux, what we have here, it's use a hybrid architectures that combine diffusion and transform techniques, while Stable Diffusion is a diffusion model that using Gaussian noise to encode images. Well, if you look on the performance, Flux generally perform faster than Stable Diffusion. And also as an image quality, Flux is, for example, better well generated human autonomy, like for example hands, with fingers, as a more accurate and efficient to handle some intricate compositions. However, the Stable Diffusion is much better in producing photorealistic options, especially when its fine-tuning is needed. Well, if we look on Origins Flex developed by Black Forest, they actually team behind the Stable Diffusion. And as well, those two different Stable Diffusions and the Flex provide different models that is probably suit for what your needs is. So think about this. The Flux was built from same team who did Stable Diffusion, but it is a little bit more optimized and look a little bit different how it's work inside. Well, let's go ahead and start working first on installing our ComfyUI. All links to the products we're going to use in this video will be down below in descriptions. And all of them, what you see here, it's a free access for you in use. However, if you decide to support developers, that is greatly appreciated. Installing ComfyUI, an initial step, it's extremely easy. All what we need to do, going to the link in a GitHub, again, link down below. Go to GitHub ComfyUI. If you scroll all the way down, where it says installing, you need to download it, the zip file. You can use it 7-up zip or WinZip or any other software. This is a self-contained package, so it will have everything inside, which is kind of nice and very useful for us, because then you don't need to install additional versions like Python and other things. They will be locally contained to the directory. That is called mobile installation. It means you can just take this directory, put it on different drive or different, and it technically should work. However, when we will have problems, it's when we need to install specific models, control net, or additional modules that are going to work. I found personally it can be a problem as well. In some cases, you may have a problem to accessing specific functionality because it is mobile install and it's not necessarily will work with global variables. So before I actually download this, let me also share with you a couple other links that I highly recommend you install it before. It's very possible you already have installed some of these applications, but just in case if you're missing them. So the one I'm using, WinZip, you can use it 7-up or a zip file or any other ones that allowed us to extract a zip file. I will provide links down below for you. This is pay or free to use forever, but it's give you a reminder. So again, if you want to support developers, I would suggest to some kind of reward them for the work and efforts. Another things what you want downloaded, it's a Git. Git allowed us to connect to remote repository and download it code directly on your machine. In some cases, the code will be included, or for example, when we start working with packages, they may be self-downloading, but I highly recommend again install the Git just in case if in the future you decide to expand your knowledge and also work with a different type of packages beside ComfyUI. Another one, it's a FFmpeg. This is one of the critical components that you will require if you work with AI generative animations. FFmpeg allowed us to take images, videos, disassemble them on separate frames, and as well take separate frames and put it in single animations. Almost all animations that is freely available to generative AI will utilize FFmpeg. Next, this is mostly not downloaded, but do create accounts on these next sites because it will help you access specific content. One is Hugging Face, and this website where some repository will be reside, and you would require sometimes login to this or authentications to receive it special access to the mostly AI models or checkpoints to download it on your computer. And of course, another one is GitHub, another place where most repository is created. And if in the future you see yourself as a developer, this is a very good place to have it your own space where you can share your developing and your work with another developers. Another place where I recommend for you to get it login, but this is not necessary. It is on a Civit AI. This is central place where they have a different checkpoints, different models, LoRa's or other components that you may use it in your future AI generation work. This is will kind of ask you to create your login, and you can of course using login by utilizing Google, Discord or any other login, so it's have it very nice. Just only beware, this is not safe for workplace images. However, you could going and check and disable what rating you can see. So it's kind of allowed you a little bit filtering, but just general, if you disable everything, it's a lot of stuff that maybe you don't want to see will appear here. Just beware of this. This is a resource, it's not safe for work, and I want to recommend for you to access from your workplace. Well, let's start with our first step, and it is going and download it one big zip file. All what you need to do, click on this direct link to download and then specify place where you can load it. I already have it multiple installations, and by the way, it is allowed you to have it as many installations as you want it, and they will be isolated. So it's meaning if you think you want to experiment with the different components and you don't want affect the model that already working for you, your installations, then you can go install another ones and proceed from this point. And it's actually what's happening. I have it about 5, 6, 7, I don't know how many even installations. In one place I work specifically with the new components, they're experimenting when I change models, path and other stuff, and sometimes it's clean. It's like in this case, I will have another new installation just for this video specifically. And you can see right here, I created ComfyUI demo folder, and inside I'm going to copy this file. So we'll go ahead and save, and it is downloading our package. When it's finished downloading, it's about 1.5 gigabyte. That is not full size of this file. This is just initial basic. And if we open a zip file, you can see we have it right here, Windows Portable. So we can even drill down, and on this case, you can extract directory itself, but because I already create called demo, I'm just going drag and drop these files inside my other directory. Well, it's more than one way you can install it. This is very flexibility, and it is the best part about the mobile install for the Windows, because you can also take how you want it and install in different places, and you can even move around afterwards. These installations also allowed you to connect central based of the models. I will explain a little bit later what this meaning, but think about this. If you have some checkpoints that you downloaded and they're quite a bit large size, can be 6, 7 gigabyte or more, and you don't want to re-download it for every new installations, then you can create a special directory, so special place where you have shareable models and point your new installations to utilize those models. After it's finished extracting, we're almost ready to start launch. If you look in directory, you'll notice you'll have two files, run CPU and run NVIDIA GPU. Technically, ComfyUI can run on AMD or Intel processors. It also can run on the NVIDIA card or AMD card, or can run purely on CPU as well. It can run with Linux, Windows, Mac, or other versions. So it's quite a bit universal applications, which is why it's gaining its popularity. Well, for you running, you can run NVIDIA or CPU, but before we do this, we need to be sure we have it special checkpoint models. Checkpoint models, it will have it all necessary informations or optimized and trained models to generate specific images. Let's verify first, and in the future, it's where also you can connect them. Remember, you don't necessarily need to keep it in this place. You can keep it in central, and after it, through the YAML, you can configure, which we can show later. But just in case if we have it one installation, so let me show where we can have it. And we're going to our ComfyUI. We'll go down to the models directory, and right here we have a checkpoint. And we look inside checkpoint, we don't have it anything. So in some installations, you may have it a basic checkpoint to use it, but usually it's very large files and people don't put it in. So we need put it checkpoints here. In this case, it's where we're going back to places like CivitAI to download it, those models. You of course can download them from GitHub or Hugging Face. Just check for the checkpoints for the ComfyUI or general the models or checkpoints. So when we're on CivitAI, it's what I want to show you right now, we can go inside the models directory. And as we're inside models, again, just let you know, in my case, it's only PG and PG-13, so you won't see all models in this case. And I want to be sure it is set like highest rated, or you, for example, have it highest, most downloaded, or other things. So the one that I'm going to use is Geekatplay Excel. This is great models. Also, kind of pay attention because some of these models can be Excel model as the Excel, so they all have a different. For our example, we will going to use a Geekatplay Excel. I also probably going to put it something more like maybe Pixar models or other things. Those models that specifically train on some style of the renders. Okay, when you have your models, you can go ahead and just put it. I'm already pre-downloaded before, so I'm just simple drag and drop this model inside, and you notice it is about 7 GB, so it's quite a bit a large model to use. Well, at this time, I think we almost ready. It's all what we needed to start work with ours. Next, we can go back to our top where we have it and run NVIDIA GPU Bath. Before we run, let's go ahead, look inside what is that batch file will do. And you can see it's just a simple executing Python. Notice it's have it embedded Python, so it is a local installation of Python file. If you want global, you probably want to go to python.org and download it model from there if you want to use Python on a global. And the next, you just run main Python script here as standalone in a Windows. If you have it problems and sometimes you may missing some installations or does not work properly, then inside the update folder you probably want to run some ComfyUI and Python dependency installations. However, it's not necessary. If we're going to run for the first time, you'll notice it will start downloading packages that we're missing, and this may also take a little bit time. So I'm just double time click to run this, and let's see if it's find some of these packages or it says I need to download them. So right here, recognize my NVIDIA card, it's 3090. As well, it's recognized some PyTorch. And I have it all dependency, so it's open here. Well, because I used it before, it's actually saw some of my previous work and kind of open. What I'm going to do here, we're going to delete all of this, okay? And we're going to recreate. And as we're recreating, I will explain what is each component does here. As well, we probably want to go and install additional components. What I said before, ComfyUI by itself it is UI shell that allowed us to run and work with different model and different components. But sometimes to access these components, something will help us manage them much better. I'm not yet sure why not yet ComfyUI use this. It's manager, not manager, but I highly recommend for you to install this even before we start working, because it will help us to download it and recognize some components much easier way. And the component first where we need to install it or want to install it, it's called ComfyUI Manager. Links down below. And you can see it will provide a very nice interface for kind of working with this. You can do this actually a little bit later as we're going along, but I do prefer install and create some environment on the beginning, so we don't need interrupt our work and downloaded components like on the middle of the creation. So for this, we actually need to go and download it from GitHub. So right here, if you can see, we have this line where we want to copy. As well, we're going to ComfyUI custom nodes. So let's go ahead in our ComfyUI directory. We're going to ComfyUI custom nodes, and we need to install here. For this, I'm just going to type on top with a prompt and type CMD for command prompt. And as well at this, it will be nice if you already have a git install. You remember I said recommended things, because what was happening here when we paste this line, git its special command at execute, and it will access to this path and clone or copy that repository on your computer. The difference between cloning and copying will be independent and just resided. If somebody modify your repository online, it will never synchronize and get latest code. Cloning is allowed us to make copy with linking to original repository. So it's meaning if somebody update the latest code, you can also execute command that will already know, going verified and downloaded. And some of those commands like git fetch will check if it's updated, and a git pull will pull latest code to your machine. So in our case, we'll just do this and you click enter. Notice as it's downloading, we do created additional directory called UI Manager, and it is downloading some code. So let's go inside this directory and look what is actually downloaded. You can see some code. Well, let's back to our ComfyUI. By the way, the ComfyUI, it's web-based UI, so you access to your web browser. It did not show here because we need to reload this. So you have a couple things. If you reloaded just browser, you can see nothing happen because we actually need to go and relaunch our code. So the server application is still running. It's creating special program run on your computer, and that is what call a server because it serves specific functionality to us, and it's currently running. And as it's running, it did not read special those files, configuration files that is reading on beginning. To stop server, all what we need to do, just close this window. After we closing window, we just need to go back to our demo ComfyUI and launch this batch files again. When we're running, you'll notice it will open second window. So it won't reuse window that's currently connected. It will try to relaunch new windows. However, if you have any work was there, it will save it and access. So right here, it's preloading, and you can see it's downloading some of the components that was probably missing. And there we have our new window open. And you notice down below, now we have manager options is available. Before we jump to create this no floats and explain how does every component work, let me go and show the very, very basic. If you already know this, you can skip to next segment. But just in case, if you don't, it's maybe help you, I will show you the very, very basic and very simplified way how it does work. You may be familiar with this image and you saw before, where is the from noise coming denoising, so it's come image, and in the end you have image. You maybe saw this process or steps happening as you're creating generative AI. So what's happened on beginning, you'll have it create a random noise. Well, technically it's not random because nothing the computer is generate is random. It's simulating pseudo-random. But it's creating some very noise. By the way, that seed number that will look later, random seed, it's what will generate. And if you're repeating same seed number, you will have it exactly same noise pattern, which will most likely generate very similar image. Maybe different on small details because those noises, they're overlaid. But general, it is, think about this, we created noise. Next coming denoising, and when the noise happen, the another things kick in that says, does this image look closer to what I wanted? And if it's a look closer to the, with recognition, text recognition come closer, then it's proceed in more steps. And by the way, it's have several steps, which will you see later, happening, how much noise need removed. And as removing noise, it's try to add or generate different details. And of course, our model, like recognitions, image to text recognitions, can look on an image and says, does that image same as what text was put it in? Well, this is one way. Let me go a little bit on a smaller level. Hopefully to understand how they actually training and this happen in this model. Okay. Right here, it's very basic flow. I mean, the basic we can get in. And by the way, just let you know, this one was using early in 90s when developed special AI model I was developed, so we was working on those models. So whatever you work right now, it's not revolutionary and big. That was developed by many different programmers in the 90s. It's only different, now we have more powerful computers, more memory, so we can combine those simulation of the neurons or things much more the computer can process. But this will hopefully give you a very basic understanding what was fuzzy logic and other things, and you understand how on a single cell, kind of on single things, training is happening in your model. Again, this is super simplified, okay? So let's say right here, you have value, and by the way, each when the image getting, and you'll see it is encoding, for example, from variable, for example, from the text or from image encoding to the special space, it is convert to these numbers. It's all it does. It's take our visual, convert to the numbers that can work. And let's say right here we have numbers coming. Y, for example, equal to 5. And if we're going from scale 0 to 1, maybe it's a gray color or some wherever you want it. But it's a Y, it's what here it's expecting by conversion from text, from the image to text, it's what expecting there will be specific value. So Y is 5. And when we're creating with this noise, we can creating from value from 0 to 10, again, as example, and this is variable. So what's happened here, our X, it will be any random generated number from 0 to 10. That's what specified. For example, it can be 1, 2, 3, any number. Next, we're going to the conditional validations. It's where in some cases you says, does this look what I expect? In this case, it does not look what I expect. So it's going back, and now we're increasing that value to validate our condition. For example, we have it A plus 1. So when it's going next circle, it says, give me a random number from 1 to 10. Of course, because it's a random, it could be a give you already 9 or 10 and pass these validations even with this. But if it doesn't, your lower level of the random will temporarily come closer and closer and closer till it's reached this value. So this value of A, it get trained, it's get modified to match closer and closer to the value what you're expecting. Of course, because we're generating random values in this case, this way, whatever you're creating, it's give you this different output on the end. If you don't have random, you will receive exactly same image all time when you render. This is what give it this little flexibility. Again, this is just one component. Take this and multiply by millions of the times. That is where you have it more complexity. And they're not just going in one condition. If you saw the other schematic, you're going in multiple different layers. After this, going to another like this and another. So it is how it's worked. And again, this, let me clarify, this is very simplified model. If you're interested more, I would recommend for you to take the AI courses when they're going to different type AI models and kind of train you. But hopefully this will node and kind of flow to help you understand what we're going to do here. So right there, we have our playground, and this is our canvas. It's our area where we can put it nodes. And nodes, it is symbolized as representation of specific components that process some specific operation. So to load it, first node, we need create. You have multiple ways you can do. You can right click, go to the nodes and browse to all these nodes. The other things is I like it. It's easy. It's just double time click and you open search nodes. So in our case, we need to start with one first. It's loading our checkpoint. That is our base. So let's go ahead and click load, and we have it our model checkpoint. There you go. So this is our basic. Let's see what we have in our checkpoint. Let's go look closer. What is on our model we have it. This is load checkpoint, and if you notice, we have it model, clip, and BAE. So the model is one of the crucial diffusion model we're using. So the function of this is model. It's entirely apply a diffusion process, removing noise from the image. And the image actually already kind of located in latent space. Think about numbers. It's not the image as what we see on a picture. It's more mathematical representations of this image. So in the checkpoint in the model also include those pre-trained weights that allow to understand the patterns, textures, features in this latent space. Think about this. That is collections of the reference images inside the mathematical representations of those images. It's like you have your own gallery. And as we're speaking about your own gallery, if you are an artist who try to draw something, and all what you know in yours is how to draw a cartoon. And if I ask you to draw something, your style will representing and style of the cartoon. So in this same things, why we say this model will better work for this, because if you only learn in your model, in your library model, only with anime, whatever you produce, you'll be kind of working only with anime style. Or in this case, if we have a more realistic view, whatever we produce, it was a reference. And this is a reason why the models, you'll see all different models you can download it, because they're kind of specialized on specific styles. Of course, you can create maybe a super large model, but that will perform much slower, and you will be limited to how many latent space you can use it, because remember in previous when I showed the simple logic, you have only limited how many of those connections you can use it in specific models. And it's why you can see they have an XL model, XXL model. It's all of these different sizes. But general, it's very good idea to load it different models. Some, for example, different diffusion AI generations, like in a Midjourney or other things, they're using dynamic preload models. So it's kind of identify based on the text you're putting what style or what you want to do, and it will utilize that preloaded specialized model to generate what you need. But however, they even sometimes not perfect. It's why in Midjourney you're using like Niji type tag or other thing. The clip is going for the constructive language image pre-training. So in some ways, whatever we put a text in, the model need understand, it's need convert. So in this case, it's take our language or text prompt and convert to the vector representation, to mathematical vector representations of ours. So in some cases, it's have this think about a digital map that is need to reference what is looking. And the clip model will be referenced over when we have steps. So what's happening? You have this noise going to denoising, remove little bit noise, go back to our clip model and says, does the image that right now we have it getting representation from what person put it in text? And if it does, it's going to next step, or it start over. So in some cases, the clip is during image representation, it's process text prompt into the vector representation, and this vector is matching visual elements, enabling model to understand the prompt meanings and generate the image that along with this. And as I mentioned before, the clip is providing guidance and a feedback for the model on each steps, helping to ensure the generated image is reflecting the text prompt. There are also components as a part of the checkpoint. The clip checkpoints include the weight for the both text encoder and image encoder. So because it's kind of in one model, it will include both of them. And this has helped us very effectively align what you see and what you write. So text and image, in this case, it's very well aligned. It's the reason why they will be included in the same model. The variation of the encoder, what it says was VAE, it is responsible for encoding because how the model is trained, it's have their own encoding in their own latent space in different model may be slightly different how they encoding and handling all this stuff. So this has allowed us to encode and decode text or images from latent space to the image or a text prompt. The encoding is happening during training or during the image generations, and we encodes image into compressing latent representation or mathematical representation where the diffusion model will be operated. And our decoding, it's after diffusion model has generated the image in this latent mathematical space. It's decoding back to high resolution image for in a normal pixel space. So it's actually what that. And of course, this is include two things. It is an encoder and a decoder. So it's take a text and image, create a latent space, and after one generation, decoding back. So this is actually one of the main model. And this is a model that we downloaded from the Civit AI and use it here. You can see how it can create. And if you want a different style, just keep in mind, change your model so you can find some more interesting in a way you want the style. Well, if we have our model here, our next we actually need to process something. Think about this. This is not processor. It is library, yes. But now we needed somebody who will read this, who actually take, categorize, work with all this stuff. And it's here called case sampler. So let's create this. We'll double time click and we'll just go down here and we'll find our case sampler. So we have a case sampler. And we also have some advanced case sampler, so depend which one you want it. For now, let's just use it very simple one. And as we're going here, you'll notice we have our model, which we can easily just go and connect. And by the way, the nice things about about ComfyUI, if I don't have this and I don't know what to connect, I can just simple take this, drag, release, and as I'm releasing, notice it is come up with the help menu, which already have something that I can connect very easy that related to this. In this case, I can just select case sampler from this. So it's very nice and useful, faster way you can connect. Okay, and we connected model to model. Next, what we have here, you'll notice it is text and it is condition. It's called positive and negative. So let's just drag and drop one, and as we're doing, you can see right here we have our text clip encoding, we have our conditions, so we can create additional nodes. And as we're creating, it's create one clip encoding and connect to positive. Notice we have also additional connection called clip. Well, let's go, this clip should connect to another. And from previous, what we saw, the clip, it's help us to take the text and encode in our mathematical, so the mathematical model will understand what it does. And in this case, because we're connecting, it is positive to positive. Well, let's go create negative now as well. We'll go create another one. And we're saying we're going to connect this to the clip. And now we have a two, positive and negative. Well, as you work with some nodes, you'll notice they become too many, too messy, hard to understand. Well, I do like make little bit organizations. It does not do anything to functionality what we're doing, but it will help you to easy to find and manage with this. First, let's go change our text, what is about. And I'm right click, going down to the title. And right here we have it text, and let's go just as positive, so we know what it is. We'll go ahead, click OK, and you can see it's changed. As well, we can right click, go to the colors, and I just will use it green color. So just know positive is green. And when we go into negative, so we'll go click on title. Let's go to negative. Okay, and we'll go right click, going to the color, and we'll change this to the red. Well, technically positive and negative is kind of tell you what is going. If I go and type create a snow princess, then it's tell what you need to do. But for example, I don't want that snow princess be inside the castle or have it more than 5 fingers. Then in a negative prompt, I can write 5 fingers. Or no more than says. And remember, you can use the human language. You don't need to use programming language. So you can describe what you don't want to see and what you want to see. Next, as we before in our checkpoint, it's a take this text, convert it to special, and when it generate image, it says, does this is image, it is a fit to those text prompts what we created. And if it does, it will go to next step, and so on. Okay, next, you'll notice right here, we have it what I call Latin image. And Latin, it's a mathematical representation. So let's go take and drag and drop this. And if you notice right there, we have the reroute, which is, don't worry, just kind of connections. We have another case sampler, which is kind of very interesting. It's mean you can nest at them. You can create one image, run through different model, so you can have it very complex. Right now, we don't need it. We just need to create a very simple layout. Okay, we have it encoder, and this is encoder if you're using regular image and you want to put it there. And we have it encoder for in painting, so you can put it image and in paint specific areas. That a little bit more advanced, we'll look in the future. And we have it empty Latin image, so let's create that one. And as we're creating, you'll notice what is happening. It's have it our width, it's have it the height and batch size. So the width and height, it is size of the image. And the batch file, it's how many variations you can produce. Well, let's speak a little bit about width and height. Original first time when they created, it was 256 pixels, but 256. Just give you different, that if you see HDTV, this is 1920 by 1080 resolutions, how many pixels there. So, and we have it 512 by 512, it's about square half of that resolution, or 1/3 actually, 1/3, 5/4. Well, I need to be better on the math. But the width and the height, it also should be related to what model was trained in. What is meaning by this? If we're using Excel models or a newer stable diffusion, they train on 1024 by 1024. In meaning training, they create a model, they have an image, they specialize this image, and they fed this image in a model. It's meaning image takes so many pixels or those nodes and establish them in a latent environment, and it will be, I think it will be 1,048,576, something like this, for 1024 by 1024. And of course, for early smallest models, it will be about 262 by 1000 by 144. So I think it's about this. You can see it's about 5 times bigger. So it's a better image, but it's as well, it's require bigger latent space. It's why on original models it was smaller. So this is much smaller, and because of that, you want to keep it to the model it was trained. So it doesn't mean you cannot create smaller or bigger, but it's meaning in a bigger image won't have it information, and because it does not have that information, it will render twice. So you will have it like if you have it render one porcupine for me. Yes, you will have 2 porcupines on the image if it's too large, because it's trying to stitch those together. And if it's smaller, it just does not get a better resolution. When utilized, you will have it extra noise. So it does recommend to use it a resolution that is model was trained on. And you can find that information easy from place like Civit when you download it, so you can see this is what model was created. And many times, actually, it's using in a names. Like if you have an Excel model, it is probably 1024, and almost new, all new, we will have it 1024 by 1024. But here's another interesting thing. You don't need to create a square. You can create a rectangle sizes, but as long your proportion and a pixel combined together will be equal to this 1 million something pixels. So that is what you need to do. Well, we kind of created. Let's go right now look what does a case sampler actually does. Let's look on some of those properties and try to explain how it's work and what is what. So in this case, we're using Stable Diffusion, and in Stable Diffusion, assemblers refer to algorithm or method used to generate final image by progressively refining it over multiple steps from initial noise to the complete image. The sampler control how the latent noise is denoised into coherent image, and it's of course playing a very important role in the quality of our image. Well, let's look on some key roles of the sampler in our Stable Diffusion. So the one we have it noise to image transitions. The sampler can determine how the noise is converted to final image, controlling the trajectory, smoothness of the transitions. If we look here, we have it our steps. In step management, it is the simpler manage the number how many steps required in the diffusion process. It's how many times the image going, remove the noise, says does it close what I want to see, let's remove more noise, let's remove more noise. And also it is the more steps usually is generating better quality of the image, but it's require longer time. However, too many steps can lead to another creating of artifacts of the image. And you know, if you cook food, you can refer to this. You can have it not done at all, raw. You can have it just perfect, or you can have it overdone, too rough or mushy. So in some cases, you need to find this and amount of the steps. It's also will related to what sampler you're using. Well, let's know next we have it of denoising methodology to understand what it is. The different samplers use a different approach to the guide denoising. And when I say it's down below, you can see right here we have it sampler and method, or this is different type of methodology it's using. Well, some may favor the details, some may be fairness, sharpness, while other ones may prioritize overall coherence and smoothness of the texture. So the different of them. Well, let's couple things look inside here. Let's look on our case sampler in more in the properties what we have. We already have it model, positive, negative. We know we're connecting those inputs. Down below we have the seed. Seed it's what creating this random noise. Well, let me refer back to this. Right here, you can see it's creating this random pattern. And of course, when we're generating, how I say nothing is random in the computer, the seed is determining what this parent is will create it there. If we put it 0, it means every time it's a random generate number, and it will create its seed. However, if you're using same seed, if you put it same number, it will have it as same noise pattern. So in this case, you could receive about same image over and over. This is work very well if you want not creating new image, if you like what you have it, and you just refine some small changes. Also, this exactly same seed number does not guarantee you have it exactly the same image if you change your text prompt, because that will work in combination. You have it a text convert, or prompt convert to the clip. Remember, it's a different model. And now interactions between the noise and changing different mathematical model will create a different image. So the seed does not guarantee absolutely identical image if you're changing other parameters, but it's will getting very close to this. So the next we have it control after generation random, and if we click down, you can see increment, decrement, so you can play with little bit different seed numbers position. So this is all for creating this initial. Next step, and a step we already cover a little bit above. This is how many denoising process happening. By default, it's set 20, and 20 is fast enough. Some models like Turbo and other ones, they optimize actually maybe even to in a one pass or in a two passes only. So then you don't need it much less steps, so they can process faster. It doesn't mean they will produce a smoother texture, more details, but they work much faster than process. The steps, and many times, will determine or recommend by the people who pre-train models. It's kind of the optimize. 20 is usually a very good start for the most of the models, and you can go higher as you need it, but remember, more steps take longer time and are not necessarily the best result in the end. Next, we have it CFG, or classifier free guidance. And the CFG is parameters that help strikes balance between the following the prompt and maintaining the model learning diversity. So in how it's a work, CFG is actually a scaling factor, and it's determine the weight giving of the input of the prompt and generated image. In some cases, if you have an artist who drawing picture for you, and you can tell them and come as a client and says, you know what, this is precisely what I want you to draw. And for example, I say I want to draw a circle, red circle filled with red, something else. And artist will draw precisely what you ask. Or you can say, you know what, I have a concept, just something roundishy with a bright colors, and then you give it more flexibility to the artist. Think about the with case simpler. In some case like this, the more CFG value you give it to stricter, it will get it to the text prompt. The less value, more flexibility. Of course, higher value or restriction not always work the best. Sometimes it's one power of AI generations. You need allowed this randomness noise to create it and not give it priority to your prompt. And also the guidance will relate it many times to how model was pre-trained. Well, it's kind of how the model was created. And in many cases, the values will stay from 7 to 15 between these. It's most models will use this value. So about 8, what we have it here, it's very good. It's allowed quite a bit of freedom and flexibility for the model to generate, but it still be sticking very close to the prompts you provided. Down below, we have it samplers. And samplers, it's a one, if you remember that, how the denoise happening and what type of algorithms and work. And people create a multiple different ones. Some may be more detailed, some better texture and everything. So if you click on this, you'll notice we have it all this big list. If you want going in details, you can look on the documentation. Here, I want to provide you kind of overlook on them. What is the strengths or weaknesses of these models and how, or their samplers and how they work. So DDIM, and I don't know if we have it here, but right there on the bottom, DDIM, it's a denoise diffusion implexing model. And its popular sample was for some times because it's offer faster generations with fewer steps, and it still maintain decent quality. The trade-off sometimes image variability and noise for the speed, so it does not give it that much flexibility. PLMS, if we look here, let me see if I can find one. We have the LMS right there, and PLMS is pseudo-linear multi-step. So linear multi-step LMS will be, and this is simpler. It's a sampler strike a balance between performance, image quality, and offering the more consistent result versus DDIM. The one, if we look on top by default, was select. It is Euler. And of course, with my accent, it may be pronounced differently. Then this is simpler. It's very popular, one of the simpler. And this is the generate a smoother, more details result. Euler ancestrals in particular, it is produce creative variations and it's how it's handling actually the noise. It's making it more suitable for generating like artistic or diverse outputs. It's why people like this one. So Euler ancestrals. LMS right there. It's what we was calling before. It's a Laplacian pyramid samplings, and they simply produce the high quality result with carefully managing the denoising process. So it's a little bit longer than other one, will take time. But it's also offering the leading and fine details by requiring longer this time. So it is more will concentrate. And this is if you have it more details, like if you work on the textures or other things where you want more details, this is actually a nice one to use. Well, we also have the DPM. And you can see DPM, DPM++, some like this. And it's a denoise diffusion probabilistic model. And simpler in advanced variations. And okay, let's look what we have it. Okay, we have it the first. It's a faster sampling with DPM++. And I remember at one time it was one of the popular after Euler. People says recommended that was using DPM++. It's the reason why. And this is simpler optimized to diffusion process, allowed you to generate high quality image with much less steps compared to other simplers like DDIM or PLMS. Then this achieved to the improvements in algorithms. So you will see probably more and more different type of simplers as people working around, they're optimizing algorithms. So in some is maybe work right now very good, you maybe find something better a little bit later. Later in. And of course on a DPM++, you have improved image quality. Well, the speed increase, but also increase the sampling. It is still maintaining very high quality of generating images. And of course, you have all these different variations because when people find one sampler, they try to adjust and play around. And the most popular is DPM++ 2S. It is a 2 steps. The version is focused on optimization of the speed of the denoising process. Then you have a DPM++ 2M. That is a multi-step processing. This variant is designed to provide more flexibility in the threads between quality and performance. Then you have a DPM++ SDE, which stochastic, I don't know how properly say this, differential equations. The simpler is particularly good on handling more complex and high detail image generations. Again, if you have one, let's say I want to create a room of the wish with a lot of library books and everything, that one will have more focus on details and create a little bit better in this case. And by the way, just let you know, when you see GPMPP, it is plus because in some representation text, if you put plus, they work a little bit different. So when I was meaning DP++, it was DPMPP. This will be for plus. So you can see right here all these models. Hopefully it's kind of help you to see how they work. Primarily, we'll use the Euler, DPMPP, DPM2, LSAM, so hopefully it will help you. And of course, remember this, it's not just things as a universal sampler. The sampler is best work if you are targeting something specific. So for example, if I want smooth and nice with imaging, I probably will go with Euler. But if I want to create backdrop, I probably will use it with a DPM++ M2 or something like this. Okay, next below we have a scheduler. And think about scheduler as a manager that control noise reduction process. It's a define how noise is removed or denoising for each step in the image generations process. Essentially, the scheduler is manage the progressions of the image and as it transitions from random noise to clear and coherent output. Well, if we look on different type of the schedules, in this setup we have a normal, cars, exponential, GM, simple DDM. Notice some of the samplers can be changed or modified depend on what versions you're using, or maybe you install some additional. But from what we have it, what I will call vanilla install as default, let's look. So our normal schedule, it is the standard or default noise scheduler. Of course, it's as we started. It's good for the general purpose of the image generations. Then other ones maybe work a little bit better on details or speed. So next we're going cars, and I saw that people quite a bit used often this one, and actually this is named after Theo Cars, and this is scheduler is used as special noise distribution parent, and it's emphasized on stability in the early stage of final details, so they won't go like very weird, awkward, and also details in the later. It's often followed by cousin scheduler. We have there, which is mean the noise is removed slowly at the beginning and more aggressively towards end. So let's say the popular, well, usually what is usually popular use? Okay, try to find proper language. What I was saying, it's very popular for high quality image generations where details is very important. It's helped the model produce details and stable output even when it's have a complex progression. So the next we look exponential. An exponential one, it is a scheduler reduce noise in exponentially decay rate. So it's kind of, if you remember from school, maybe you have this well, I'm start losing my English, okay? But like curves, the exponential curves or other things, okay? So anyway, and it's using exponential in reductions, but with scholastic random elements, making it ideal for applications with diversity of randomness of the image in details. It's very desired. So it's, if you like work on concept, anyone all different, probably that one will work better. Next, we have our sampler schedules, and it is straightforward and apply uniform noise reduction per step. So it's just exactly the same work on every steps. Next we have it here is DDIM one, and DDIM it is derived from denoising diffusion and pixel model, so it's same as we model used before. In this schedule follow the uniform noise distributions, but it's also leverage the advantage of DDM for the faster, so it maybe work a little bit better when it's going hand by hand with the scheduler, and if you set up your sampler type. Okay, so in just the case if when you will want to use it, it is very good balance between speed and details, and it's actually produces quite a bit decent quality, but it also does not use it that many steps, so it's a reason why that scheduler is work in many cases. And of course our ISKIP is SGM uniform. It's kind of same as a work on details, but it's more not linear but smoother kind of going. In some cases, think about you will probably use it the cars if you need more details. You will use it the simple or uniform but generic use it DDIM for the faster processing, and between probably normal, simple, or exponentially, it's a more generic use kind of. The last one what we have here is the noise value, and it's going from 0 to 1, and particularly here it is control the degree of the noise applied to the image in each steps during the image generation and the process. Because when you create from all image on the beginning, it doesn't mean it's additional noise won't be applied. And you'll see this heavily when you have an image. When you base generation on an image, you put it reference image, then you'll put it additional noise on top, because you do need to remove noise. You need something to work with. And in some cases, when you actually create it from here, like you have an empty latent image, which is already created noise, but as you're going in a step, and maybe step does not necessarily process properly, maybe additional noise could be applied by some models on the middle of process to add details. Because I saw some models that working, they have it generated halfway. Next, they see, okay, let's add more noise, smaller details for the creating. So you're creating general big shapes. After, add additional noise for the details. So in this case, this is apply how much noise will applied. Of course, 0, it means no noise will applied, and 1 is applied as much. The best here is find the balance between two of them. So the higher value between like 0.7 till 1. With this denoise, it will have it a lot of more details, more applied, more flexibility on creation, so you will have it diversity more applied from original image. And as more you're going towards 0, it is less this applied. Of course, this type of the noise, it's needed experimental and see what you want to create. So this is about all we want to explain, cover about sampler, case sampler. I hope you have it so far good kind of grip on this. So let's go next. What we want to do, it is take our latent in this, drag, and of course what we want to do, it's decode. So in this case, remember all of this what we're creating right now, we take our model, we're using our clip to text, we're going in our sampler where we're feeding the random generated noise image, what is based on. We did generate it here, and now we need to output and decode. And right here you can see we have a 2 input. One samples, it's from London, so it's that mathematical generated image. We'll say image right here, but now we need to decode. And of course, to decode, we need to know how to decode. In this case, you can see we have it right here, connections going straight to our VIA. It's supply on this variation variables, how it is, what decoding table to use it, yes, to decode this image. Okay, so our next step, we needed this image displayed, and right here you can see we have it image output. If we drag again, drop it, then we have it set options, and we have it two what we're looking on at now, save image and preview image. Preview image just allowed you to preview, and save have the option to save it. I would probably recommend select the save options, because in this case it will save on your computer. Notice we also have it additional encoding and encoding in Paint, so we actually can have it our generated image created and after save it some, well, in process for the next one if we need to do maybe an animations or a based image. It's up to your imaginations, and we'll go look in the future that. So let's go click save image, and we have here. So at this time, if you check, this is a complete, a very basic image generated. So before we start doing, let's overview. We have it our model preloaded, we have it our positive, our negative conditions text. We also have it our generations for the image, the basic one. We have it our sampler set, and I will leave it just by default here, what is the noising work. Next we have it our image decoding, and we have it our image creation. So let's go ahead and try type something. Fluffy puppy. My imagination's that big for now. Fluffy puppy, and let's say ice. I don't know why. I don't want ice. I want green field. Fluffy puppy, running on the field. Well, of course, my misspelling, so I'll need to spell properly. This is done. And when we're done, we just needed Q prompt. First time when you click, it will take long time, longer than usual. And the reason is we can preview here because it will be loading model. So let's go ahead. We'll click Q. And as we're doing, you can see it's in a ComfyUI. It's telling you what step it is. Like right here, you can see it's creating green box. It means it is processing that step. And if we're going to look in our server, you can see it's a preloading. So because you remember it's like 7 GB, it's quite a bit large model. And it's need to take this model and preloading in our memory. So it's need loading this. And also need to assign all special using memory and GPUs and other things. So it's kind of start processing this stuff. But right here, it's taking model and opening. Well, I'm going to pause for a second this video till the model is loading. Well, okay, here we're done loading model. Now it's a sampler. It's gone very fast from reading all of this stuff. And now we have our image. Look right here, we have our image is created with a funny running puppy. So let's do a couple modifications and see how it's work. For example, in a clip, let's go say white fur. So I don't want white fur. And let's set batch file. Okay, right here. Maybe we'll say 4 images. Yes. Also, we can try to modify type of the sampler. General, if we have it, we can change model, but I won't recommend to change too often because it does take quite a bit time to load it, mostly initial load. When we start doing it right now, you can see how much faster it will process. However, I want to change from my sampler. Let's go to more details, DPMPP2M. So we'll select this. And from our sampler, we in colors, which kind of very good, but more details. Should we go? I think colors, yeah, colors will work very good on this. And our denoise value, we can leave it a 1 for this because it will generate from image, but we always can go just preset to 0.07 just to leave it as this default. As well, notice we have our preset random image already, and we can just leave it similar. And instead random, we'll go fix it. So we'll have it as same seed for the puppy that we created currently. All what we modified a different sampler, and we modified negative. Because we're going to create 4 batch files, but with the same seed number, let's see what's happening then. So we'll go to Q, and you can see it will process quite a bit fast. Now we're going in a sampler, and a sampler process 4 images at the same time right now. And here is done. Okay, well, let me increase a little bit in size here. And you can see we have it 4 images. Well, some of them white fur, it was brown, but you can see one image still have a little bit white fur, but general is okay. And let's look somewhat similar because we have the same seed number, but the images look different. So let's change, for example, from this to random again, and just compare how it will do with this. And here we have it similar images because they're using of the seed. Well, let's say this, it's fun to create some images. What if I want to base it on my own photo? What if I want to take some image and use this as a base and render, just add some details or other things? So for this, we need to take it area here where we create empty noise image and replace it with an input image. Let's do this way. Let's go. We'll destroy these connections. We don't need any more. Yes. Oh, right here. So let's delete this image. Instead, I'm going from latent image, drag, and we actually need to use it encoder, because remember, at this time, all of this area, it's in a mathematical kind of latent space, and we need to take and connect our image. So as we're connecting, you can see pixels. Let's drag, and what we're going to select load image. Well, this is our preload image, and this is using some example. It's come with Stable Diffusion. And also on our encoder, we need to know how to encode what using. And for this, we're using our model encoder, same as we're using for the decoder here. We'll go in and connect to the encoder. So it's meaning we encode with exactly the same latent space, all our image encoding and decoding. Okay, next you can choose or uploaded image. And I'm just going to upload an image of myself. And let's go say clown. Okay, and we don't need negative for this. So I just want, well, let's explain a little bit better. Yes, portraits of the classic clown. Okay, so we'll make a clown out of me. Okay, we have our image selecting, same things, we're using same model right now. And in a sampler mode, we can change. So we can go basic to our Euler, what we used before, and maybe here, let's go back for the fast and use it, DDIM. So we'll use that one. But again, if we need to use it for details, we can always going to more normal or simple. It's just nothing smooth, nice texture. Okay, and I think this is all what we want to do here. Let's go click on Q parameters, and you can see it's gone very fast because model preloaded in our memory, sampler doing, and there you go, we have it, our image. Notice we have it, my portraits, and this kind of a semi-close. The noise, it's what value we spoke before. Let's take our value and reduce to 0.3. So we'll say closer or more far away from the text. Remember, the one, it's a more flexibility. Let's click Q and see what's happening. So it's actually take an image and apply noise on top of the image and after remove details. And because I says apply smaller noise, you can see it's getting much closer to my original image. Just apply small details. As well, there is where you can look for better balance. So example, if we increase by 0.4, a little bit more, we should have a little bit more details now in here. And again, as we're rendering, you can see more details added. And of course, 0.6 will create even more details in this case. Of course, properly utilizing model, utilizing correct samplers and schedulers will give it you better different result. And here you can see it's even closer, well, kind of closer. Yes, it's using this with short. Let's switch a little bit, for example, from Euler. Okay, we're going to use the DPM to M again for higher details, and from our normal DDIM, so we'll use this one, and let's click on the Q. So we have it now. We're going for more details, creating more details in a texture, and you can definitely see it's add a little bit more details in our image. Okay, oops, so let me see if I can increase in size, kind of right here. There you go. And if you can see, it's much more add textures and details, and because we're using a sampler method which provide more details in our image. So far we was looking on a basic functionality of the Stable Diffusion with using ComfyUI. So let's go look a little bit more advanced that will give it us much more flexibility in an interesting way to create. And of course, one of them, in some case almost required right now, it's called control net. So if we're looking on a control net, you can have more information from the link down below. You can see the white papers for the who interested, see how it's worked, but general what it does, it is take input image, analyze in different ways, and it's very many different ways can be analyzed. You'll see this in a second. And based on this can provide as a reference or guide an image or guidance what we can do. So one of the most popular in a nice way to do it is or using the depth map, so it can isolate object from the background, or can use it the guidance for the poses. So let me find very fast ways the guidance. You can see like right here. You see how those lines done? It's like almost posing, so you know precisely what person look, which direction, position of the hand, fingers, and so on. It's going to apply also to the animals as well. So this is what control net help us. By the way, you can use it control net to animate by in specific way by using animations. Well, how you download it and what you need it. If you remember before, we did install Manager, and Manager will help us take those files that we're missing or we want to look and install on our machine. So the control net have it multiple different packages or nodes that we need to use it. Of course, we need to use the model. The model is help how it's reference and encoding, how its AI should process pre-trained model. We also need to have a model that is will take our pose and pre-process. So it's analyzed in specific way to extract information. And then we need to use the control net to combine all of them together before we're going to feed this to K sampler to create for us. And because I says before, it's meaning it will need go somewhere from our model, our text, and K sampler. And in most cases, it will be right here between them. Well, some control net nodes already pre-install it when you have it ComfyUI, and some we need to download. Let's go ahead and download first what we needed. For this, we're going to use the Manager, and be sure you install Manager before it's our in previous video. And inside here, we're going to download models. So we'll go first to the model, and in a model, let's search for Unify. Just type Uni, and you can see right here is have control Unify. What this actually does, it's take all of these different models and make them combine in one, which is make much useful. Also, you'll notice here we have it for the flags. We also have it for the Pro Max. What we interesting in the control net plus all-in-one control net. Just click install. In my case, you can see already pre-installed this a little bit before, so we can use it. In some cases, if you reference to the central place of your models, it maybe already will show installed if you install in other locations. But general for you, just click install, and it is take 2.5 gigabytes, so it will take a little bit time to download it. After this, it will ask you to refresh, but not yet. You can refresh if you're going general. The same, it says reload, that it's need to reload all OS. That I do recommend to reload it, because anytime when you reload your server, it's actually will go online and pull all dependency that needed and install them. And if you have it multiple packages installed and never reloaded, it will try download a dependency for multiple packages, and it's maybe conflict. So be sure you have it reload after you install new dependencies that is require on new packages that is require reloading. So in this case, you will avoid some of those conflicts and maybe bring your system is non-workable state. Okay, we downloaded model. It should be easy, straightforward, and it's require only refresh. Okay, next, let's go ahead and we need to preload some custom nodes. So inside custom nodes, what we're going to do, it's using auxiliary processor. So just search for ComfyUI auxiliary, and you can use it right here. You can see it is installed, but it is having some conflicts happening, which is okay. And in some cases, you may have it several options. So let's look. If you just search for auxiliary, you want a ComfyUI ControlNet Accelerator to install it. And in some cases, you may have a different ones already pre-installed in your case. Okay, after you install this, that will require a restart. By the way, I will give you also very good link to the specific ComfyUI wiki, where you can go and check all things that they recommend to install, or you can install. This is one of the best manual. You can use it here. And as well, you can check what they recommend. If you go to recommend custom nodes, just click on this. And right here, you can see what they recommended. Same like right there, ComfyUI ControlNet UX. You can copy this. And that's what we actually did it. We paste it and we just install this actually. So be sure it is all installed for you. The other ways you can also verify to be sure everything installed. If you're going to ComfyUI custom nodes and check here. Well, in those cases, just I want to cover, I would say, every possibility. If you have a hard time installed through UI, which is very unlikely, but just in case, then you can go directly to ComfyUI Control Accelerator. And if you scroll all the way a little bit down right here, you can follow this alternative installation method. And you remember how we open command prompt in directory. So you'll do same things and you just copy, clone this, just follow all of these instructions. It says in a case if it's failed. But I installed 5-6 times already and it's actually worked just fine going through this. Okay, after you install it, you may need require a few times. Actually, for me, I installed first time in these installations was have a problem. Then I says try fix it, restart again, and after this it's work fine. It's loaded and everything there. Okay, so let's verify what we're going to do here. Well, this is my preview image I don't need right now. This is our previous, it's what we created. So we need going and put it ControlNet somehow connect to this. Let's double time click and we'll just type ControlNet. And as we're going, you can see right here, we have it load ControlNet model. Well, we also need this. We have it also apply ControlNet. So we'll need that. And let's go right now, and we have it also preprocessors and all these other things. Well, let's start with loaded ControlNet. And as I'm preloading, you can see my ControlNet model that we have it. It's found and already preloaded. And I'm going to put it right around here because there's we're loading normal model and there's we're loading our ControlNet model. Okay, next we can go drag and drop and you can see what's happening here. It is actually give me prompt what I want to connect. I'll go connect to ControlNet apply. Well, and this one actually, if you notice, if you do this way, it's showing old one. We don't need to use it old. And I show you the reason why, because you see condition control, it's very small navigation which does not work. So instead drag and connect, we'll just type it, double click, type ControlNet and click on apply ControlNet. You'll see it's different because we have more options now connecting. And let's have it positive, negative, ControlNet, image, and our variational. So we can connect variational from our model here. We can connect our control node here. And this is what we're going to place. You see they have it positive, negative, and we have it two of them. So I'm going to connect positive to positive. And we'll go connect negative to negative. But now we have it output. And those ones will just replace in case simpler. So just like this. There you go. Now we're missing one image. But this is not just your image. It's actually will take a normal image and as a map, and you can pre-create maybe in Photoshop and other areas. But in our case, we need to take and analyze this image. So let's see what's happening. If I go drag and drop, it's actually give me all of these different properties, but it does not give me preprocessor. It's what we want to use it. For this, let's double time click, and we're going to use it AIO input output, actually preprocessor. So we'll select this one. Okay, and where's my actual processor now? Okay, that is up here, and I also have a preview image, which, you know, it's pop up accidentally. I did it, but let's keep it because we need that one. So I have put this right here, and you know what, let's readjust a little bit our position. So I'm just going to select my image here, decoder, we'll move case sampler, we'll put it this above, so with nodes, and now we have our preprocessor going from image here, connect to preprocessor, and now we need connect image, and I'm just going to connect to image that I already have it. Well, the reason is why I have a preview image, I want to see what preprocessor will do. So in this case, we'll take from here and connect. Again, resolution, we can set the resolution we wanted, but general we can actually change. We can analyze what resolution the image is and feed in. But I think 124 should work. We can also switch to 512. Well, we almost done, but we not yet have any preprocessor selected. Well, if we click on preprocessor, you can see we have a quite bit long list of these. Some of those names does not tell you anything. So it's very nice if we have some visual reference. And actually we do have. And it's the same to the link was before ComfyUI. If you scroll down here, you can see some of these preprocessors, and it's showing you what they can provide for you and work. So for example, if we can have a depth, we can have a depth anything preprocessor. And if you scroll even more down, they will have it even more examples here, what you kind of looking. And in our case, I want to use it open pose. So I'm going down right here, it says open pose preprocessor. Well, I think we're almost done with the least first test. Let's click Q. And as we start pre-processing, okay, let's go to see what we're going. Right here you can see green, so it's preloaded those very fast. It's a pre-processing right now. And here's image, and let's just increase a little bit. You can see it is processed face, so it did identify I have it face, and it's placed. Of course, if we're going to increase in size, you can see the face is adjusted, and there you go. So we did create our image. Well, I actually accidentally, I think I clicked twice. It's why it's happening. But there you can see we applied our image to our face. So it's creating expressions. Of course, we can check this and change maybe on something different. And in some cases, well, animal, I don't think I will work as an animal. But we can look on all of these different types. So let's just example canny ages. We use this one. So let's click Q. And you can see how fast pre-processing. So it's outline, creating different. And as we're processing here, now we have this kind of overlay. Well, let's see how it's work without overload on our image. For this, we'll just double time click. Actually, you know what, let's go from our image, we'll disconnect this, and we'll just go drop here and create our simple empty latent image 512. Well, let's go to, we'll have it 1024 on both of them. So right here, okay, there you go, we change this, we don't need it. This encoder, we'll keep it image as a reference for the face. Okay, and we'll go just render and see. Notice it is already pre-processing, which is nice. It's cached, it does not take all the time. It's just instantly going to case sampler and use it already images that we created. And there you go, we have a new image right there, you can see, and it's based on the same facial expressions what I have before. And of course, this is canny, and canny use it outline. You can see how the hair, beard, everything. If you want more poses, remember we want to go and switch to the open pose preprocessor. In this case, it will be just taking positions of the mouth, eyes, other things, or if you have it full figuring, like right there, you can see applied. If you have it full figure, it will apply inside here. Okay, let's go look, and there you go. There we have it, our poses render. I definitely need to change what sampler I'm using and other things for this, as well as the my text prompts. And here definitely different result if we're switching to the like Euler and normal. So it's just different samplers will work. But again, this is our start point, how we can use it with a control net. Thank you for watching this video. In our next video, we will explore Stable Diffusion 3.5 and a Flux inside a ComfyUI. So we'll see you.